Hey geometry students, it's Miss Goldenberg coming at you from home. I hope you guys are all doing good. I hope you guys had good weekends with family, staying home. So this is my first video, and these videos are typically going to have to be in 2 to 3 smaller videos because the free video recording website that I found can only do up to 15 minutes. So I might have to do 2 to 3 depending on how detailed the topic is. So what I'm going to be doing is I'm going to be walking you guys through our next topic. So we're still in area. Right now we're still in our Unit 8 area. Looking back through the different days that we've done previously, we did rectangles, we did parallelograms and triangles. We moved on to, if we look back, day 2, areas trapezoids. Day 3, we did oh, that's still day 2. Day 3, we did kites and rhombuses. Day 4, we were doing area two-ways. Remember, that was more of an honors topic. Day 5, we were doing some review before we did a quiz. I'm still grading those, by the way. I will have those done soon. And then day 6, we did polygons. And the big thing with polygons, remember, was we were breaking them up into triangles. Now, some of those polygons were a little bit harder if you had to solve for what they called the apothem, which if I had, a hexagon like this, if I broke up my hexagon into triangles, the little height of the triangle is called the apothem, and it's spelled like this. Now, the ones we did in class were a bit harder, and we had to use different tools to solve for that height, such as trig. We used 30, 60, 90 triangles. Those were 2 that we saw. I think you guys saw in the last homework assignment that's due today that sometimes it's a little bit easier and they give you the height of the triangle or the apothem, and you can just right away plug that in and solve for your area. Then last Friday, the new topic we did was the area of a circle. We looked at the circle area formula, we looked at the circumference formula, and what we're going to be doing today, day 8, we're doing composite figures and shaded regions. And if I just kind of scroll through what we're going to be looking at, a lot of the area is looking at different shapes that are made up of multiple different figures. So we've got, how to find the area of, in this case, like number 2, I'm seeing triangles, I'm seeing squares or rectangles. It looks like it's a little bit off from a square. But basically what this is going to be is a really good day to practice just all the different areas we've done and look at areas where we put different shapes together. So our warm-up is to practice doing our circles and our polygons. So number 1, we're going to practice a little bit of shaded region. And shaded region typically has a couple of big idea steps. So looking at this, if I'm trying to find that shaded region, notice it's like this little darker bit. Your first step is we're going to need the area of the circle. Second step, we're going to need the area of, it looks like I've got a 6-sided figure, which is a hexagon. And then my third step is I'm going to take the full area of the circle, subtract the area of the hexagon, and what's left is going to be that shaded region. Okay, so that's kind of our big picture steps. I'm going to move this over to the side, that way I've got some space. So step 1, I'm going to find the area of my circle. Now, thinking back our area formula, we have pi r squared for a circle. So I need to figure out what the radius is. And let's look at what they told me. They told me that the hexagon is regular, which means all the sides are equal. So I'm just going to mark those real quick with tick marks. And they also told me that it has side lengths of 4. Okay, so it looks like it might be a little bit easier to start thinking about the hexagon ideas. So I'm looking at this, and I don't think I can easily get what the radius is without doing some work. So we might have to first think about hexagons or first think about the smaller triangles. So let's see, it has side length of 4, which means if I focus on one of my pizza slices, remember it's going to be 6 total triangles. If I focus on this one here, I'm going to redraw this triangle. We know the side length is 4, right? That's the side of each of the outer sides of my hexagon. And let's see, a hexagon, remember if I do 360, the total circle degrees divided by 6, because there are 6 triangles, it's going to come out to be 60 degrees. And what that means is each of these is going to be 60 degrees. Now remember, this only works for hexagons, where it works nicely like this. If I divided by a different number, like 5, if it was a pentagon, we saw an example last week where it didn't work out quite as nicely. So that means I've got a 60-degree angle up here. If I draw my height, it's going to break that angle directly in half. Okay, so what I'm going to do is I'm going to draw in my height. I'm going to label this as 30. And remember, since that angle is 60, that means we have equilateral triangles, so I know the bottom angle is 60. You also could do 180 minus 90 minus 30. I'm going to redraw that smaller triangle, a little bit bigger. So I've got this triangle. The little base is going to be half of 4, which is 2. And I'm looking for the height, right? I want to find height. Using my 30, 60, 90 rule, I'm going to take the base, and I'm going to do the base times a root 3. So my height is going to be 2 root 3. Okay, so I'm going to kind of label that in my picture. My apothem, or my height, is 2 root 3. And I might scooch this over to the side just so I have some space. So that was like the first thing I had to do. Led us up to here. At this point now, I can find the area. I'm going to first maybe find the area of my trapezoid. So I'm going to do like kind of my step 2. Or excuse me, not my trapezoid, my hexagon. So I'm going to find the area of my hexagon. Okay, so the area of the hexagon, and I'm not sure why this is popping up. There we go. The area of my hexagon, I need to first find the area of one triangle. So the area of just the triangle is base times height divided by 2. Remember, we want the total base, which is going to be 4 all the way across. The height is 2 root 3 divided by 2. So if I'm looking at the top, I'm going to do the 4 times the 2. So that's going to be 8 root 3 divided by 2. I'm going to do 8 cut in half. And that looks like there are now going to be 4 root 3s. And that's the area of just one of my triangles. Now, if I want to find the total hexagon area, I need to take the area of a triangle and multiply by how many triangles there are. So I'm going to do 4 root 3 times 6. Remember, that's area of a triangle. 6 is number of triangles. And for this, you can do just the 6 times the 4, the coefficient, and you're going to have 24 root 3s. And that's going to be my hexagon area. Some of you guys might want to write that as a decimal. So if I pull up my calculator real fast, if I was to do this in decimal form, let's just give it a second to turn on. There we go. If I was to do this in decimal form, 24 times the square root of 3, it should be about 41.57 if I rounded it to 2 decimal places, because the 9 after the 6 is 5 or greater, so it's going to round it up. I'm going to leave my answer as 24 root 3 for now. We might write our final answer with a decimal, though. So I first found the area of my hexagon. So I've done that. Now I need to find the area of my circle. Now, the trick to doing the circle is the fact that our triangles, each of those pizza slices, if I look at them, the base is 4, and if I have 60-degree angles, what that means, I'm going to look kind of over here. Because I have 60-degree angles, remember that means that my triangle is equilateral. So all of my sides are actually going to be 4. And what's going to be helpful about that is if I look at, for instance, this side, I'm going to highlight in the bigger picture. Notice that side is going from the center all the way to the outer edge of the circle, and that means your radius is also going to be 4 as well, which is kind of nice. So if I'm going to do my step 1 of my area of my circle. So area is pi times radius squared. So it's going to be pi times 4 squared, or 16 pi. Now my last step is I need to do subtraction. And so far I've done kind of my step 1, my step 2, just kind of in a different order. And final step is I'm going to say, okay, the circle, which is bigger, right? Notice that's the bigger outer shape. Take away the hexagon. And I'm going to do that on my calculator so you guys can see what that would look like. So I'm going to do 16 times. On my pi button, if I click second and this button, notice the pi is above it in yellow. So 16 pi is about 50. And I'm going to do minus in parentheses 24 times square root of 3. Now, depending on what calculator you have available, you might have to write this a little differently. You might have to go more in smaller steps. So I'm going to write it down, 8.696. 8.696. I'm going to just round it to like maybe one decimal place. So I'm going to round it to 8.7. I'm going to put units squared. One quick calculator thing, if you subtract and you got a negative number, that would have meant that you subtracted the smaller amount of area from smaller amount, take away the bigger. So you want to be careful. You want to make sure that you are doing the bigger amount, take away the smaller. So that's a good way to like double check if you have an error, if it comes out being negative. Okay. This one was an honors challenge on our warm-up. And for this one, we've got a hexagon as well, and side lengths are also 4. So it's the same hexagon that we were looking at up above, right? Same hexagon. Now, this one's a little trickier because we have to figure out the area of the shaded region, and it's kind of like 2 chunks. So it looks like there's our regular hexagon, and it kind of looks like we've got a rectangle here. The trick is just how to figure out the rectangle's area. Because what I could do is I could do area of a hexagon, take away area of a rectangle, and get my shaded region. Now I can clearly see that my rectangle has side lengths 4 here. The trick is how we're going to get the tall straight up and down sides here. These ones are actually pretty tricky to think about. The trick is if we were to reintroduce our triangle, if I reintroduce my triangles into my picture like that, what you'll notice is that the green side length is actually going to be exactly the same as, I'm going to use a different color. If I drew in the apothem or the heights of my triangles, notice it's going to be 2 apothems stacked on top of each other. And in the last problem, remember this is the same picture, we found that the apothem was a 2 root 3. So what that means is my green side, because it's the same as the 2 heights stacked together, is going to be 2 root 3 times 2. We can write that as 4 root 3s. Okay, so I already found my area of my hexagon up above. I know my area of my hexagon, so if I do hexagon minus rectangle, it's going to be 24 root 3. It's the hexagon. My rectangle is going to be 4 times 4 root 3, right? You can write that as 4 times 4 is 16 root 3s. Notice we're just multiplying the coefficients. This is really, really similar to if I did 4 times 4x. You'd write that as 16x, right? Same idea here, just a different variable attached to the coefficient, so to speak. From here, I see like terms. So this is why I really like to leave my numbers and my answers in terms of pi, in terms of square roots of 3, because now I can just do 24 take away 16, right? And if I do 24 take away 16, we're going to get 8 root 3. Units squared as our final answer. And you can just leave it like that. If you want to do it as a decimal, that's totally fine. Okay, so just looking through our warm-up, the honors is a really nice extension, right? The key to the honors is looking at the full triangle picture. Both of these problems, the biggest thing that I suggest is kind of like I put here and here, making a plan for how you guys are going to be finding your area. So I like to think about the big picture before I get into the nitty-gritty. Okay. So the next thing we're going to be doing our actual lesson itself. And before I transition, I just want to say that generally, if you're doing the warm-up, a really good idea is to try it on your own, like do as much of the warm-up as you can. And then from there, I would suggest going to the video and watching it with the explanation, comparing your answer to mine, seeing if we agree or if we disagree, seeing if you noticed something or did it in a different way than I did. So I'd really suggest doing your warm-ups individually before you go to the video and try the video. Okay, looking at the time, I'm getting really close to my 15-minute mark of what my video can go up to. So I'm going to do the notes in the next video. Okay, see you guys soon.